Hello friends, today we are going to see a tutorial on the friction asperities. So title of this today's topic is the friction and elasto-plastic deformation in asperity solution. So here in that thesis that writer has been given that two materials he has taken and he has made geometry of that two materials. I will show you. So here the writer has been shown two asperities so I will show you. So here he has shown the top and bottom surfaces. He has taken the spherical surfaces like bearing or the gear, we can consider that. He has calculated the stress by Hertzian context theory, as well as he has calculated by using that console. So here we are going to see the problem statement, and as per that problem statement we are making the model, and that model we are simulated here in console. So here in that problem they have given he has taken that length of that rectangle is 26 microns. So he has used the unit of the micron. So we will see the one by one. So here in that model he has taken the plane strain model. That model is 2D model actually, and this is actually the material properties of top asperity and bottom asperity. So we are here using that. So first we will see the dimension of this top asperity and bottom asperity. Okay, so this is the thesis PDF. So I will see the dimensions. So actually here when I will check that dimension 26 mm. Okay, so here he has taken that height of that rectangle is 10 micrometers and length of rectangle is 26. So here also we will model this. First we have to use that we have to open this console multiphysics software, and after opening that, actually this friction asperities or friction and contact will be simulated into a solid modeling. For that purpose, first we have to open that console software. Then after opening that console software, we have to use open the model wizard. Then we have to click on that 2D because we are drawing that 2D model here. And after opening that, we have to go into a structure mechanics. In structural mechanics we have to click on the solid mechanics. That solid mechanics will be used for these simulation of that stress analysis. So you can read from here also, and after clicking on that solid mechanics, here it will ask to us. So we have to click on that solid mechanics study. Then we have to click on time dependent. After clicking on time dependent, because that friction is time dependent property, so we have to click on that and then done. Then what will happen, our physics will be get open, our required physics will be get open. So here it will take some time to open that physics. So as per requirement we will model it and we will solve it. So here now this geometry or these windows will be get open. So first it will ask to set unit. So first we have to set unit that asperity is in micron, so I will set micrometer in it. Then here I will click on geometry. After clicking on geometry, I have to make a rectangle. That rectangle having width of 26 and height of 10, that is mentioned in that. So here they have mentioned that the rectangle width is length is 26 and height is 10 micrometers. So as for this I will make this and I will build all object. So here we will get the rectangle. Okay, next is the, here is the circular geometry is there. That semicircular geometry has a radius of 5 micron. So I will draw the circle of 5 micron. I will click on circle, then radius will be the 5. I will take sector angle is 180, and then I will click on build objects. Then it will ask us to set a proper position. So here I will set x-axis will be 13 and y will be the 10. So after that I will click here, so it will properly get fixed on that geometry. Okay, next, now this bottom geometry is prepared. Now we have to draw the top geometry. For that purpose I have to click on geometry again, or you can create you can use that same rectangle. You can take duplicate of that rectangle also. By right clicking that, you can duplicate it, and we can see that the location of this. So here this will be the top. So I will measure dimension. The height of that rectangle is 10. 10 plus 15, 15 plus 5, that will be the 20. So y will be the 20. Y will be the 20. So I will build object, so it will come at top surface. Okay, so as per requirement I have drawn this. Now we require to draw this sector. So you can copy or you can duplicate that circle also by right clicking on that. So after that I have created that circle, and that circle has radius of 5 and sector angle is 180. Okay, but location I have to change. The location of that center will be here at center. That will be x13, that is right, and y will be how much? So we have to measure that 10 plus 5, 10 plus 5 plus 5, 10. So that will be the 20. So y will be the 20, and this sector angle will be 180. Okay, now it is created, but that is at top, so we have to rotate this. So you have to go into geometry, you have to click here geometry and transform this object with the help of rotate command. So we have to click on rotate, and then we have to select this sector, and we have to give angle of 180 degree. So after building that, this will be get rotated, but location will be get changed. So we have to give location once again. That location will be at 13 and y will be the 20. So here, as for our requirement, our geometry will be get set, and here now I will do union of these two geometry, because this will be the top asperities and this will be the bottom asperities. So as for our requirement, I will make union by right clicking, and by doing boolean operation we can do that. So first I will select top and build. Then what will happen, this top geometry will be get ready. Now next I will you can copy this command once again, because we have to do union of bottom geometry also. Okay, this second I will select this. Okay, so build all object. So now this bottom and top asperities is ready. Now we have to use a geometrical command. Geometry, once again we have to go into geometry, and we have to do motion, because we have to move these top asperities. So I will give motion. I will select this top linear. Okay, and I will keep as it is. Now next step is what? Next step, we have to give material. So here we have to click on material and we have to select blank material, because as per our requirement they have given the material property also. So here they have given the material property also. Top Asperity is material property, bottom Asperity is material property. After clicking on the blank material, we'll get that basic materials, that Young's modulus. Young's modulus they have given the for top asperities. I will first select top asperities. 210, 210 GPa, 210 GPa. So I will click on that. Poisson's ratio is 0.3. Density of top asperities. Now this top asperity is hard and bottom asperity is the smoother. So here I will give that top asperity is harder to 7750, that is equal to the steel. Okay, now next I have to add the elastoplastic material. That material is elastoplastic material. So as per requirement of that elastoplastic material, here I will add that material property by clicking on material property. After clicking on that material property, we'll get the various types of material properties, basic acoustic, basic properties like. So here I have to go into the solid mechanics, because I mean now the physics of solid mechanics. Then I have to click on elastoplastic. After clicking on elastoplastic material, again there is separate module for elastoplastic material with the initial yield. So by clicking right, we have to add material and we have to give the properties. So here this isotropic tangent we have to give 1, this kinematic we have to give 1, hardening function and initial yield that they have given. The yield will be the 1000 megapixel. And that hardening function is 4500 megapascal. Okay, so I have given the material for top asperities. Now next I will select same, or we can copy also this, can take duplicate of this material same, and we'll change the properties. Okay, now this one number bottom asperities. So this Young's modulus is 160. So density I will give 5000. That initial yield they have given the initial yield of 600 megapascal. Okay, so now we have decided all material properties. Now we have to go into next step is we have to go into definition, and we have to do contact in between that two asperities. So we have to click on that selection explicit. Why we have to give explicit? Because with respect to time this load is also varying. So now we have to select boundary. So here we have to give contact or top. Same we can copy or do duplicate of that. Now only we have to change this. Okay, now I have done the two contacts for these two asperities. Now we have to give the contact pairs. have to go into pairs, contact pairs. After selecting that contact pairs, we have to first select top, then second will be the bottom. Now name will be we can change name also. Here that will be the bottom. Okay. Now next is after that, now we have selected material also. Now in solid mechanics, now we have to fix that bottom geometry. So with the help by clicking right, by clicking on fix constraint, now this bottom geometry is fixed. Okay. Now next step is we have to give the gravity for top asperities by clicking right, volume forces, gravity. For top asperities I will give the gravity. Now next is we have to click right, or we can add the contact pairs. Now by clicking on plus, we have to add that contact pair which we have defined into a definition. Now that contact pair will be get added. Now this formulation we have to do that formulation by using augmented Lagrangian. Okay, so as per requirement we have completed this, and next step is now we have completed all steps which is required for the modeling of this. So we'll see how the modeling they have done in that thesis. So they will get that figure here. After that we can see that okay, so these types of modulation should be there, simulation should be there, and here on time dependent also we have decided. Now we can compute with the help of compute tab, and we'll wait for result. Till that result we will see that this is the that friction is the time dependent property. It will take some time. I think it will take 2 to 3 minutes. Till that time I will pause. Now that simulation is completed and that result is ready with respect to time. Okay, we can do animation also. We can change the unit of that also by clicking on the unit. We can change that coefficient of friction also by So this will be the result. So we can add the coefficient of friction also here. So by clicking right in that solid mechanics step, we can add the friction. Okay, so we can add the 0.3 friction, and then also we can compute. It will take some time for computing. So this is the conversion plot. So this is the reciprocal of time step and size. So this solution is completed. So here we can add the simulation also or animation also. So we can click on that layer, and we can play that. So in that way we can complete that simulation, and we can read that all result from here. Okay, so thank you.